solve the quadratic inequality and then write the solution set in interval notation, we have x squared minus 4x minus 12, which is greater than 0. Okay, so here's our quadratic inequality. Now, the first thing we need to do is we need to find the interval boundaries. Okay, so how do we find the interval boundaries? What we need to do is we need to factor the quadratic inequality. So let's go ahead and do that. So the first thing is we're going to write this out as if it was a quadratic equation. So we have x squared minus 4x minus 12, and then set that equal to 0. Then we're going to go ahead and factor this. So the leading coefficient is a 1, so we just need to write negative 12 as the factor of c, that's the constant of c, and the value of b is negative 4. So what two numbers can we multiply to get negative 12? When we add them together, we get negative 4. Well, it's going to be positive 2 and then negative 6. Positive 2 times negative 6 gives us negative 12. 2 plus negative 6 gives us negative 4. So therefore, we now know that we have x plus 2 times x minus 6, and that's equal to 0. Now we're going to use the 0 product rule. So we're going to set x plus 2 equals 0 or x minus 6 equals 0. Solving for x on the first one, we get x equals negative 2 or x is equal to 6. Okay, so now we've found our interval boundaries. Okay, so now what we're going to do is we're going to go ahead and graph on the number line. So we're going to create a number line here. And so on this number line, we're going to go ahead and then put in our boundaries. So we know we have 0, we have negative 2 as one of the interval boundaries, and we have positive 6 as the other interval boundaries. So that means we have interval 1, interval 2, and then interval 3. Now keep in mind that we go from negative infinity to positive infinity on our interval. So the first interval goes from negative infinity to 2. And then the second interval goes from negative 2, and that should be a negative, negative 2, comma 6. And then the third interval is going to go from 6 to positive infinity. Okay, so now we determine our intervals. Okay, now that we've done that, now what we're going to do is we need to find testing points to test the quadratic inequality. Okay, so looking at the first interval, what we're going to do is we're going to take a testing point. And what is that testing point? Well, we need to pick a point in this interval. So we're going to pick negative 3 in interval 1. So x is going to equal negative 3, and then we're going to plug it into the quadratic inequality, x squared minus 4x minus 12, and set that to be greater than 0. So we're going to plug in negative 3, square that, minus 4 times negative 3 minus 12, and see if that's greater than 0. Negative 3 times negative 3 is positive 9. Negative 4 times negative 3 is positive 12. And then that's minus 12, and that's greater than 0. Well, 12 minus 12 is 0, so 9 is greater than 0. Is that true? The answer is true. So that means it's true for all values of x that we pick in this interval that'll make that statement true. Alright, so now let's take a look at interval number 2. Well, the easiest number to pick in interval number 2 is 0. So let's pick 0 and then plug it into the quadratic inequality. So we have x squared minus 4x minus 12 greater than 0. So we're going to plug in 0, 0 squared minus 4 times 0 minus 12. We want to see if that's greater than 0. Well, that gives us 0, that gives us 0, so we have negative 12, which is greater than 0. is that a true statement? That is false. And so therefore, it's false for interval number 2. Okay, now let's take a look at interval number 3. Okay, we're going to pick a value in there, so we can pick 7. So x is going to equal 7. And again, we're going to plug it into the quadratic inequality. So we get 7 squared minus 4 times 7 minus 12. We want to see if that's greater than 0. Well, 7 squared is 49. 4 times 7 is 28. Minus 12 is greater than 0. 49 minus 28 is 21. Okay, and then 21 minus 12 is going to give us 9. And 9 is greater than 0, so therefore it's true. So it's true for that interval as well. Okay, so now that we've figured out our testing points, okay, we determine where it's true and where it's false. Okay, so now that we've done that, now we can now decide what is the solution to this problem. Well, we need to determine where is it true. So it's true for what particular intervals? Well, it's true for interval 1. It's true for interval 3. So therefore, the answer to this is, okay, we know that it's true for interval 1, which is -infinity to -2. And it's true for the third interval, which goes from 6 to infinity, and we're going to connect it with the union symbol, and so therefore that's the solution. So let's go ahead and type it into our problem to make sure that we're correct. So we're going from -infinity to -2. So parentheses -infinity, comma -2, and select the union symbol, and then parentheses +6, comma +infinity with the parenthesis. Let's check our answer, and there is our result.